Alright, so let's look at this example before we move on to the volumes. Right, so we have a cool example right here that's saying find the area of the region bounded by the graphs of, we have, this is MATH141. Right, so we have what? X equals to 2 minus y squared, right? And we have what? We have x equals to y squared. Okay, let's try to do this. Okay, so the first thing that you have to do, please load down your mind and relax. Okay, the first thing that you have to do is to sketch the curves. But if you don't know how to sketch the curve, well, I'm just gonna tell you later on how to try to do that. Let me just put it right now. Okay, the matter case is, if you don't know how to sketch the curves, right? And then this is a clear example. So suppose that we have y is equal to x squared and we have y is equal to what? X plus 2, whatever. Okay, so in that case, you want to know which one is on the top, which one's on the bottom. Okay, so in that case, remember that when you're doing your tutorial problems, you'll be given some complex functions, complex curves, complex graphs. So you will have to sketch those curves. But now, let us say you don't have time to sketch those curves. But the only thing that you have to do is to identify which one's on the top, which one's on the bottom. So the way how you do this, so let us say we have an interval, -1 all the way to 2. Okay, that's going to be a 0. So this is our interval. Okay, so those are bounds. So in that case, the only thing that you have to do is to plug in the values that are in between that interval. Right? So let's try to do it. We have to choose the easiest one, which is 0. 0 is in between this interval. Right? So it's equal to, this is going to be 0 squared, is going to be equal to 0. And then right over here, y is equal to 0 plus 2. We're going to have our 2. So you see right over here, 0 and 2. So 2 is greater than 0. So which means that this curve is on the top, right? And then this one surely is on the bottom, right? So that's how you identify. So right over here, if we come to this part and say, okay, what about 1? Let's check. What about 1? So in that case, if you substitute 1 right here, you're going to get to 1. You see that? 1 squared is going to be 1. And then if you substitute 1 here, you're going to have 1 plus 2. That's going to be 3. So now you see that 3 is greater than 1. You see that, right? So which means that this is still at the top, then that is in the bottom. So right over here, the area is going to be equal to an integral. Okay, what are the bounds? -1 to 2, right? What is the top curve? It is going to be x plus 2 minus what is the bottom curve is going to be x squared. And then you will have your dx. This is what you will have. Okay, I didn't sketch any curves, but this is what I have. Just to verify that, so we're just going to try and sketch it just to verify. Okay, we have x squared, right? That's your parabola, y is equal to x squared, right? And then what about the second one? This one, x plus 2, right? So on an x plus 2, we're going to have something like that. Okay, so yeah, 2 units up, right? So it's going to be something like that. So right over here, you see that this one is on the top. When you draw a vertical line, this one is on the top, this one is on the bottom. That's why we say right over here, x plus 2 minus x squared, because this one is on the top, this one's on the bottom. We need that area, right? That's what you need. Okay, so yeah, this is the example, right? How to just find which one is on the top, which one's on the bottom. But we're not there. Okay, so we're just passing right on the point. Okay, so right over here, let us just try to solve this. We're given that, right? So they're going to give us the intervals, the bounds. We're going to try and find those bounds. How can you find those bounds? You make these two equations equal, right? So right over here, we've got x and x. So we say 2 minus y squared is equal to y squared. Okay, you're going to have this to find the point of intersection. Right, so right over here, let's just transpose everything. Then you're going to have 0 is equal to 2y squared minus 2. I guess that's going to be great doing like that. Right, 0 is going to be equal to, take away 2. We have y squared minus 1. Right, so y is going to be equal to 1. and your y is going to be equal to minus 1. So right over here you see that we have 1 and minus 1. Right. So let's try to sketch these curves. Okay. So you have this. First of all, if you rearrange that, right, you're going to find that, okay, fine, this is going to be y is equal to plus or minus, you can see that, plus or minus the square root of x. Okay. So which is like this. Okay. This is just your positive, and that's your negative square root of x. Okay. And then now you can see right over here that this one is just negative, but now it has been shifted 2 units, right? So it has been shifted 2 units, so we're just gonna go the other side. Okay, going to the other side. Now they need this bound, right, this area, because it is between those two curves. That's the area that we need. Okay, so now you can see right here, this is quite different. If you draw a vertical line, okay, look at this part. Which one is on the top? Okay, let me just highlight this. Y is equal to square root of x. Which one's on the top? This one is on the top, so which means that this is on the top, but again this is also at the top, at the bottom, right? So it's the same curve. This one is on the top, on the bottom it's the same curve, same as in this side. So this one is on the top, is on the bottom, but it's the same curve. So yeah, it kind of confuses us because it's going to confuse it, because right at this point, right, this is just the same curve, and then this is also the different curve, which is going to be equal to that one at the top, right? So how can you solve this? So the fastest way to solve this is to say, oh, this is going to be your right minus left. It's just pretty simple, because these curves are different, right, when you're going from right to left. But when you're going from the top to the bottom, it's very different. You must have your error number 1, okay, and then you must have plus your error number 2. That will give you the total error. Okay, the error number 1 plus the error number 2. Okay, how are we going to do that? Alright, so we can do it separately, saying that this one at the top minus that one, and then this one at the top minus the bottom part, and then you're going to compute everything. Okay, that's how you're going to do that. Right, you find the error for the first part. Okay, so the bounds right over here will start from 0. Okay, so it's going to be integral from 0 up to 1, because there's going to be a 1, right? Because right over here you're just going to have this minus 1 right over here, and then this is going to be a 1, then this is going to be a minus 1, right? So right over here, plug in the values right here, you're going to get your 0 and 1. So in that case, you're going to have 0 to all the way to what? To 1, and then you're going to have to put error plus the second part, which is from 1 up to 2, right? This is a 2, from 1 up to 2, right? From 1 to 2, and then you're going to put out the error, which is going to be equal to the total area. Okay, that's how you're going to do it, this problem. Try to complete it, and then it's going to be pretty easy. But the good thing to understand is that you can use 2 methods, right? From right to left, which is the simplest method, or the one that you have to divide this into sections. You'll have your error number 1 and your error number 2. And then when you compute those errors, you're going to find your area, right? It's the error that you need bounded between these two curves. Cheers.